Yeah, there's the chat. Okay. All right, we are now live on YouTube. Very nice. Need to fix up. Doesn't figure out the thumbnail right away, so I gotta. Okay, did it figure out yet? Okay, got the two chats pulled up. Hopefully you guys can hear me all right. I should put the Discord link in the live chat on YouTube again. There's the Discord link in the chat. I also need to tell my Discord channel that we are just like post reminder over there. Okay, and I've now posted that in the Discord channel. So I think I've got everything set up correctly. Right. Cool. I think I've got, yeah, everything should be set up close enough. We're still giving it a few more minutes for people to join. I'm going to kick it off in about 7 minutes. Yeah, I'll see you guys then. And the topic for tonight is CAPTCHA, like Google CAPTCHA. I had actually, Yeah, I didn't have this thing pulled up in the, there we go. So this thing, that's what we're designing tonight. It's hard to balance having so many windows open on the screen. There we go, that'll do. All right, see you guys at 10:45. All right, it's 10:45. We can go ahead and start. This is going to be a horrible problem. This is not actually, I've never heard of this problem actually getting asked before, is design CAPTCHA. So this is going to be really hard tonight, actually. I've still been trying to sketch out the design a little bit more off in my other window while waiting for 10:45. Let's go ahead and export that right now. Boom. Okay, so that was a couple iterations of trying to draft it for the session, but this is going to be this is going to be pretty tricky. There's a question in the chat. Do you post all the live streams after they are done? Yes, it's going to stay up on my channel. Yep, it's going to stay up on my channel. So if you go over here on my channel, you just head over to the live tab. It's just going to stay right there. I'm not going to take it down. I always leave the live sessions up. I usually trim off the first 15 minutes while I'm just quiet and waiting for people to join. I haven't done that in a couple of videos because I've just been busy with other stuff. But for like the older ones, I trimmed off the first 15 minutes where I'm just quiet the whole time. But yeah, it's going to be up on my channel. I'm going to leave it there. So no worries. And that was a question from the chat. I'm not just randomly talking about meta stuff. Yeah, it's going to be there. Okay, how do we also make a request on the topic? I got a form, or you can drop it in the Discord. Yeah, there's a form. I think it's on my much older videos. I haven't attached it in a little while. You can, if you join the Discord link on in the live chat that I posted, I'm pretty responsive on there. I'm trying to get better with YouTube though. Let's try and switch gears more towards the topic though. So it's a CAPTCHA. It's this thing. Oh, I can close this window finally. Okay, so tag new images with labels. So you're gonna have these images coming in and we want to get them labeled. We want to find all the pictures that are of buses. And also we're gonna be verifying that users are human. I can talk a little bit about some quirks that I knew of CAPTCHA back when it was just words. So like originally CAPTCHA was actually used for translating scanned pictures of books into words. There was like Google Books or something. It used to just be this service for turning these like scanned book pages into words. And so you'd have these two words on the screen. Maybe I can even pull up a picture of the old CAPTCHA. Yeah. Okay, I can find it. This is how it used to work, is that you just had these two things and it would actually not have the lines through them. It would look like this. It looked like this, and these would be like lines from an actual book. And one of them would actually, you wouldn't need to actually enter anything there. You could type whatever you wanted because it was just from the actual book, and you didn't know if it was fake or not. You didn't know whether your entry was legit, while the other one was actually checking whether or not your text is legitimate. It was actual verification work. So it's got two challenges. It's trying to provide this service, and in the process, like the value that it's getting out of it is tagging new images with labels to help with training for, like, for example, Google Images. Yeah, I don't really have any scale numbers for this. I mean, in real interview questions, you have scale numbers, but just getting the diagram out is going to be such an absolute monster of a problem. So let's go ahead and feel free to post any questions that you have about the scope of the problem or CAPTCHA itself, explaining it. I'm going to try and go ahead and switch gears into drawing this thing though. Which is, yeah, it's going to be pretty challenging. So you're going to have the browser, which is going to have user auth, trying to have, it's just like you've got a page pulled up, and it just has that prompt for like, are you a robot? And so that's what we have here. So what is it all interacting with? There's going to be, you're going to have the picture provider service. It's going to have this like picture provider service, which is going to tell you what pictures that you want to have. You're going to have an object store of the pictures themselves. So this one just gives you a link to pictures. This one is the actual picture store. And then when you're done labeling them on your local browser, you have to send the results off to somewhere. So you're also going to have the verify service. You actually post your answers to. Okay, and then we can talk about some of the other sections. So you've got this, hey, what's the metadata? And then you're going to pull in the actual pictures. And then you're going to post your results after you're done filling out the form over to this thing. So there's also going to be a metadata store. Okay. So we haven't gone through all the entry points and exit points, which is usually I start by filling out all of those first. So there's a couple of other things that we're going to have going on here. You might have some kind of image ingestion thing. So that could be coming from like the Google web scraper, the web crawler that like makes it work. You could have some kind of image ingestion service. It could be a task runner. In fact, that might even be, I'd imagine workers or some kind of task runners is actually what's going to be the means of ingestion. And we're going to call it the image ingestion service. It might not actually be a service, it might just be some worker nodes. So it's not external facing. And I'm just kind of sketching this out. You would have some kind of thing though that is bringing the images in that we want to label. Like where are these actual images coming from? It's either coming from the internet itself. It might be coming from Google's street viewer thing. Actually, a lot of the times it is from traffic. So it might be from their vans that they drive around. But somehow those images have to get ingested. And so that is the actual picture taking stuff and where it's initially stored is out of scope. We just care about when we want to do the actual labeling with CAPTCHA. And so it's going to somehow get brought into these. You're going to have to know about this metadata, these pictures over there. And then the users are labeling the data for you. So you can have your answers over there. You're going to have these entries getting stored. What we want as an output here, though, is that we're going to be getting this like tagged data. We're going to have this tagged data that we're going to want. We're going to be using that for training some models. So we're going to have a model store, like a machine learning model. Oops. We're going to have something that trains the models that is model training workers. They're going to use the tagged data, possibly the objects from the images from the object store. Those can get pulled in, and it'll be using those in order to make a machine learning model, probably a convolutional neural network. And it'll then, when it's done training it, it'll stick it into the model store. So this is kind of an exit point. I would call this an exit point of the service. Go ahead and box that. So this is an exit point. This is an entry point for a service. And then this is also another entry or exit point over here is the actual user auth. So I'm just going to kind of box those off as so it's like already just with trying to define the entry points and exit points, it's already a very tricky. Like the actual output, we're trying to get this is what we're getting as a result of the service, is these trained up data models. We're trying to produce these trained data models, or, well, I guess tagged image data is maybe the output, and then that's utilized by something else downstream. So maybe it's not really the whole models that are the output so much as the tagged data, which you're kind of getting through the verify service. So delineating what is in scope and out of scope, just what our entry and exit points really are in this problem, is pretty challenging on its own. All right, no questions in the chat. It's pretty wild. Okay. All right. Let's go ahead and maybe talk about the metadata store a little bit. We're going to have to figure out how in the heck to prioritize what's getting provided over here. We're going to need some stuff that we know. If we just go ahead and feed the browser a bunch of unlabeled data, then the user could just select whatever the heck they want. And how do we know if it's if they're giving us good data or not? Some of it does have to actually be properly labeled. So we're going to have some data that we know for a fact is labeled properly. So some chunk of whatever's getting passed over here has to be like known for a fact to be properly labeled on both sides, as in some that are definitively a bus and some that are definitively not. And we can even do some tricks with confidence interval or something. So even if it is fuzzy data, it's like we could, yeah. Okay, let's talk about the schema a little bit. So we're going to have this metadata of, it'll have image URLs, like where it is stored on S3. It's s3.aws.com/object bucket. Something like that. And then I think you like run, so you're not really interested in data that is really obvious to the model. I think you like do this thing where, so you've got images initially stored, and then I think you like run, you might manually go through some data just to have an initial set done by contractors or something, I think. And then you just train the model off of that. You have like a poor model. And then whatever's really on the fence for the model, I think, is what you would be wanting to run back through the service and try and get a stronger, tags on those for the fuzzier data that's harder for the model to label. I've seen that there's this like confidence score that you would usually get from a machine learning model. And so anything that's like on the fence and harder, it's harder for the model to figure out, you would be able to send over to users to investigate and tag for you. So you have an image, and then you're trying to get these tags. So you have something like bus, and then you'd have like a confidence interval of like 0.90, or is it like a bicycle? You have a confidence interval of if you like, no, this thing is definitely not a bicycle. So 0.05, you're pretty sure it's a bus, 0.90. And you have another record. Let's say for this other one, the bus is at 0.55. We're not really sure if it's a bus or not. We know it's not a bicycle, but we're really interested in whether or not this one is actually a bus. And so this is the kind of one that we would want to have get sent to a bunch of users for labeling for us. And but we also want some that is definitely a bus and some that is definitely not a bus. So let's say this one is definitely a bus. We're pretty confident with it in the model. And then let's say we got some other one that is definitely not a bus. Let's say bus gets a score of 0.02. So we want some of this, and some of this, I think, getting passed over to the user. I'd imagine, so you probably have this in like a OLAP store, and you can run this job to select up a bunch of data that you want to have picked up by the picture provider service. I think you'd want like an even mix of confident data and unconfident data like this getting picked up by the picture provider service for labeling. And it's the first record and the third record that you can use for the actual human verification part, while it's the one in the middle is where you're getting your free data, your free tagging service. Okay, so designing that's a little bit, it's figuring out how the heck to get this mix of like pre-selected stuff, trying to figure that out like on the fly. Like you don't want to do that query of picking out a good mix of data to get labeled. I think you would like have I also mentioned that you would pre-run, you'd have like this initial run of all the data through a model before giving it to the users. And I haven't even discussed like where this initial confidence thing gets run through. Okay, so you get the images in, and then we're going to have this run one of the models. You're going to want to run the model off of against your data. So I think we're also going to want to do something with do that. You might want to have which version of the model that you have these labels off of. So that way you would know if it's probably good to also know which version of the model. Okay, let's take this. I think I need a little bit more space for trying to work with this. So we've got over here. And then I guess we'll have some kind of like the labeling service. You're going to use this to get like an initial rating, an initial confidence rating on all of your objects that you're going to run. You have that over there. It's going to need to read in some of the data from over here. It's going to need to read in some of the data from over here. And it's also going to then write the data to the metadata store. And then you can use that pre-labeling stuff. So this should be some kind of OLAP store. This should be some kind of OLAP store. This isn't something that you can, this is definitely not something you can have that's prod facing. Okay, and then we would need to have something else for the actual picture provider store. That would need to have a different, that would need to have some kind of OLTP copy of the data. We would have this. Have an OLTP copy of the data we're working off of. And that's what the picture provider service is going to use. And you somehow have to figure out what's going to go in there. Have workers that occasionally pull some data out for, occasionally pick data that you want to use for verification. You have just call it like the data picker service or something. Okay, so we have the image data gets ingested into an object store and a metadata store. I guess I don't really see any issues with sharing the object store for the exact, for both LTP and the having the data model running over here. I guess I could add a little box for the data model too. It's gonna have some version of the data model over there. Show how this kind of gets deployed or something at a later point. So you ingest the data to these, you do an initial run of the data model, or you're doing iterative runs. Your confidence intervals are going to, over time, get better. Maybe that's called a feature store. Maybe this is a feature store. It's a feature store is this thing that like normalizes the data to a, well, I don't know if feature store does model versioning, but let's maybe keep it a little bit simpler. You ingest the image data, you're going to have the actual images over here, and you're going to have metadata on the images over here. You're going to want to label the data with iterations of your model. And so it's going to, so you have some iteration of your model that's deployed, and you want to do a labeling of your data with whatever you've got. You ingest both, and then you stick your label onto the metadata store. So this is a little bit like a data warehouse. Yeah, I think I talked about this a lot in the machine learning videos I did a while back. But another way that you can kind of refer to these is like a data warehouse. When I was at Amazon, there was a lot of change data capture where we just kind of like had our OLTP databases, and we were always just kind of like sending off a copy of our data like downstream into the ether. It was just like this Kafka stream, and we just copied all of our records and sent them downstream to this like opaque data warehouse thing that we had no insight into. They just wanted a copy of everything, but it's gonna that's roughly what's going on over here. It's some kind of thing with a bunch of tables that the data analysts and data scientists work on. It's like less formalized as you would with production databases. With production databases, your tables are, you think of them a lot more formally, while with data analysts and data scientists, you actually like spin up new tables and new versions of tables like all the time. And so it's, yeah, it's really weird. But when you're actually looking at so after you've labeled a whole bunch, that should be, you know, not on the production database. You also need to have like a copy of that is actually getting served up onto prod, that is somehow marking which images you actually want to have served up to the users for having them manually label. And then so that's provided there. You get the actual images, and then you're collecting up their entries over here. And you want to get some tagged data. So you're going to have a whole bunch of different entries. So I think this one would have, you would know, some of them you would know for a fact whether or not it's a bus. Some of them you're not going to know whether or not it's a bus. But for other ones, you're going to know for a fact that it's a bus or not. So I think you're gonna have something a little bit like this over in the metadata store. So we're going to be testing it for a specific tag. So you could have a tag under test. So you would have, our schema is going to have a bunch of image URLs. You're going to have a tag. I think the tag would be part of the partitioning key. So we're going to have tag like bus. That's going to be part of the partitioning key. And for each of the images, you're also going to have, it's like, is it a bus? Do you know, is it a bus? And so then that would be, is it for verification or not? How are we going to do that? So it's like flattened confidence score. You're like kind of running the floor function on it. I guess you could say, is bus true, false, null? So it's like an enum. So null is we're collecting up answers from the user. If it's true, the user needs to have true on the response. So we're going to use the same database over on the verify service too. Okay, so for the ones that are labeled true and false, that's how we're going to do the actual verification part. For the ones that are null, we want to record those. Could have, it's like entries database. It's the answers, responses. It's the responses store. I think we should have an image ID. And that could be the sort key. We're also going to have UUID. That's what we'll say it is. And then we're going to say EFABC, EFABC. So it should look a little bit like this. That's the partitioning key. And we're also going to have the sort key. Okay, and then we're going to be recording their responses for a given record that we have passed to them. So for a given image UUID, given that they pass verification, we're going to be looking at the ones where bus is null. That's what we're interested in. So if it was bus is true, use that for verification. Well, if it's null, you're using that as free labor from your users. It's image tagging labor. And so what we're actually recording in here is the response on is bus. So that was not actually the schema. The actual schema we're going to talk about here. User label response true / false. And I think we only need the image UUID because we already know everything else. And I guess you could have like the timestamp or something, but you're gonna have like multiple of this, and that's not going to be uniquely identifying. You're going to have this UUID answered by just a crap load of different users. And you're going to want to distinguish those answers somehow. So I guess you could have each response could possibly have a UUID. So you could do like response UUID, or you could even do response timestamp, because you're just going to need to distinguish each of the responses somehow. I got a question in the chat. I can go through that and we'll go back to the diagrams. I'm surprised there aren't more questions. This is like a really tricky problem. How will it help making UUID as the sort key? Should it not be image URL instead? Well, so they should be equivalent in terms of so they should have a one-to-one mapping with each other. So either should be fine. I like yeah, I guess you might be able to get away with not using the UUID, and you could just use the image URL directly. But I think usually, yeah, I think people, I've never seen cases where you actually identify a record with the URL and from like over in the metadata store. I think you would usually uniquely identify a given record with some kind of like numeric ID or UUID. Either is fine though, I guess. You could probably just go ahead and use the image URL directly. That should functionally that should work fine. I just think that usually like you try and make it distinguishable in another manner than just the URL from S3. But yeah, either should probably be fine. Okay, let's try and keep going here. So bring distinguish each. So we're showing the same image to a whole bunch of different users, and we're going to need to distinguish each of the responses from each other somehow. Maybe I should have made this text a lot bigger earlier. Sorry. So we need to distinguish the responses of each user for a given image from each other, and we want to figure out whether it's true or false for a given label. I guess you should know what tag it's going to be beforehand, but I guess it doesn't really help it doesn't hurt to have it duplicated in another spot for keeping things straight. But yeah, you should know before you're presenting it to the user what your label is going to be that you want to test for. But I think we'll record it a second time. So you have a bunch of images that you're going to give to the user. You're going to pull the images, the actual image assets. They're going to have a bunch of responses for the ones that you already are confident about a label for. You're going to verify that it matches for the ones that you're confident with already from the model. For the rest, you're going to record the responses, and then I guess you can have something that looks at those responses. So like you're going to group up a whole bunch for the ID. You're going to do like a group by over the UUID, and you're going to figure out what the majority winning response is, and then that would be, is it a bus? Yes. Is it a bus? No. And you would use that for better tagged data. So this is an OLTP database. You don't actually want to do a group by over that. So we should probably have an OLAP copy of the responses store, because you're not supposed to actually do a group by directly on an OLTP store. And you can just do change data capture with like a DB trigger or something. So you just have a DB trigger or something just right on that data store. And then I think you would probably still need to have some task runners or something that would actually copy it then directly into the OLAP data store. Here's some more messages in the chat. We'll get to that in a second. But anyways, you would have it over to here, and you're going to want to do some kind of group by, and you're going to use, so you're going to figure out your tagged data off of that. You could use that for manually marking, use that for updating your confidence intervals and making your tagged data. But that's the real product we're trying to get out of this is tagged data. And you're going to get it from so there'd be something that is going to run some queries against the OLAP store, and then it's going to put the results of that into a thing that's recording the tags of the image data. And that could be the same, this could be the same thing as that. I think we could probably, yeah, so I think it might be fair to say that this is the tagged data. And we're just going to have a task runner that just the thing that's doing the group by over a UUID to determine the tags for a specific image UUID. So it's going to run some kind of read query over that, a group by, and it's going to be writing the tagged outputs over here, which you're going to use for doing even better train of another model. That could be what I get into next is the model training itself. That could be good next. Yeah, okay, let's look at the chat. Yeah. This would be something like a natural key. All right, let me pull that up. Using the all right, that's all of our questions. Natural key is a form from attributes that exist on. I think you're right that the image URL is natural key, so we don't actually have to use the UUID. I don't know if I've actually ever seen I've never seen a URL used as part of the primary key. That's why I did that, is I've just never actually seen a URL used as part of the primary key. So I mean, it is probably a natural key, but I since I haven't seen a URL used as part of a primary key, I just like my brain just feels like there's some kind of issues that could arise from that. You're totally right though that it does look like a natural key. I just feel like there might be issues if you actually try and do that. Crappy response, but that's my 2 cents. Is it just seems like there might be issues with trying to use a URL as a part of the primary key. Yeah, good input though, thanks. You should, so group by is you're not supposed to do huge key range queries on an OLTP database. Huge key range queries is OLAP stuff. Whenever you see huge key range queries, you should be thinking OLAP stuff. And so a group by doesn't like return a lot of records, but it involves scanning over a whole bunch of records. And if you look at, I think it's like the indexing chapter, it's either chapter 2 or chapter 3 of DDIA. It actually does talk a little bit about the bottlenecks that you would see in an OLTP database versus an OLAP one. So for OLAP, the bottleneck is doing lots of hard disk scans. It's scanning, it's disk IO. It's doing a whole bunch of spinning the disk, while with OLTP, you're not doing a whole bunch of HDD scans, you're doing record lookups. And it's a little bit more of a bottleneck in terms of your like bandwidth itself. It's maybe it's like scans is a better word than IO. But it's like the machine IO, because you're just doing individual record lookups, while this one is looking over hundreds of records at a time. I might have screwed this one up a little bit, but DDIA has great content on P versus OLAP. I'd recommend checking it out. It was either chapter 2 or chapter 3. I would check that out. And group by is one of the things that would line up a lot more with an OLAP database than an OLTP one. Yeah. Oh, and I did just answer that. Okay. Oh, here it is. How to ensure the correctness of the user tagged labels. Trust. It's trust. Yeah. So I had brought up, there's this picture somewhere that had shown of like the old CAPTCHA that had the word style, and it was this, and it had the 2, and I said consistently, I think it was like consistently the first word didn't actually, there was a specific order to which one was for verification, which one was for free tagging labor. And so it was something like free tagging labor word, and then you had the verification word. And so then you could type for the free tagging labor, you were literally able to type whatever you wanted. So you could just type ass. And then like for the verification word, you'd have to go really slow. And so it'd be like this one, and it'd be like PBEBSTA, and you'd hit enter. And hopefully you did that, right? And if you did, it would go through, and it didn't care that you would mistype the word north. It would think that the word north was actually the word ass. And so people would do that. And but now with the other approach, with the ones that it has today, you don't know which one it is. Word there. I'm gonna pretend like I didn't say ass. So with this one, you can't tell which one is the verification word and which one's the free tagging labor. It could be any of them. You just don't really know. And so the user just tries their best on all of them because they can't tell the difference between a verification word and a free tagging one. I've tried to screw with it before, actually, with these ones. I would go ahead and do a crappy job on some of the ones that were like harder to think through. Like I would say this one's a bus. I would say, okay, this is a bus, this is a bus, this is a bus. None of the other ones are, except for this one. I'm going to tell you this is a bus. I'd try it out, and it would give me a hand slap and say, nope, you got to fill it out again. And I'm one of those people that likes to try and screw with CAPTCHA a little bit. And yeah, it's actually hard now. With the word CAPTCHA, it was really easy because it was like the first word every single time. You would know that one was the free tagging labor. So you would feed it bad data because you hate CAPTCHA, and you're like, screw you, Google, stop doing this to me. But with these ones, you can't tell. It's not obvious anymore. I think it's because Google wisened up to the users that knew about that. And so then the users just don't know. And then it's going to be better data, even though the users might not do it perfectly, even though the user's going to be lazy and they might even be a little bit horrible on the really hard ones. It still would possibly be slightly better data than what you would get off of it's like, so with your model, with your initial training set, you've only got so much stuff, and neural networks do well when you give it lots and lots of data. And you can also do stuff with tuning with support vector machines. This was really easy. You could tune a whether it was erring on the side of false positives versus false negatives. I think you can kind of do that with neural networks by doing playing with the skew of the data. Skew, SKEU. You can play with that, and then that would help it pick out fewer false negatives or false positives, whatever you wanted. If you did both, then you would be able to get this like specific range. You would have this specific chunk where it's in both the false negative and the false positive range on both, and you would intentionally hand that over to the users because it would fall within the non-confident range on both the models. It would, if it flips between the low false positive and the low false negative one, if it flips between both and it's not getting a consistent signal across both of them, then that would be non-confident data. You could hand it over to the user for further labeling. And then if the model sucks at labeling it, and you're giving it over to the users, I mean, the users might suck at it as well, but they're probably going to suck less than your machine learning model, because but yeah, trust is a big component of it, and just making sure that the users can't tell the difference between your verification words and your free tagging words. It just forces them to do stuff. Okay, let's look through the other questions in the chat. Some websites increase the number of CAPTCHAs you need to answer before they let you proceed if you keep getting the text. Yeah, it's what is the point of designating those also with the key as bus? How are we getting that a particular CAPTCHA is testing for bus? So that's important because you can't use one type of database for the other type. So with OLAP, there's different technologies you can use that are more optimized for one versus the other. So for OLTP, you can do DynamoDB, you can do Cassandra, you can even do Spanner, PostgreSQL. If you do like manually sharded, like you can totally get that to work. For OLAP though, there's Redshift, there is ClickHouse, I guess, is one. I think Snowflake is another. Druid, Trino, and these ones are optimized for huge, it's like full table scans is what you want to run against these. It's things that require doing scanning through like the entire thing, while this one is just like single record lookups or very small key range queries. So another one is Elasticsearch. Actually is totally fair here too. It's because that one is doing that one is a search engine. It's a search database, and so like that one, as long as you don't try and pull like 10,000 records out of Elasticsearch, you're fine with that. But there aren't any databases that can do both efficiently. And so that's why you need to have two different ones. You don't want to, you can't run a tremendous batch job against your OLTP data store, because then it would have this massive latency spike, and that would your users would then like have failed page loads and they'd have a crappy user experience. So you can't run OLAP jobs against an OLTP database. And then you don't run OLTP against an OLAP because then it just causes the same thing as that. Then you have OLTP hitting a database that's trying to do these big batch jobs. You can't do that. Yeah, so you have to split them. Also with is bus, how are we getting that a particular capture is testing for bus? Well, so the data picker service, it might, I think you might have like a data scientist like specify, this would be like a manually run thing. You might have like a user that's like manually determining, hey, I want to run XYZ thing. And so then they would have this and it would pull data from the data warehouse and it would write it over to here. So you would have the user saying, hey, let's improve our bus tagging data or something. You might do that. Or you might just notice that you're trying to add the new bus detection stuff to some other system. But I think there's some kind of manual component to determining what you want to be figuring out. And then so you select the data that you want to be tagging. So it's part of whatever batch of tagging data that you want. You load it up onto the OLTP thing, and then this pulls up some images related to whatever batch of. It's like a tagging job. You have this like tagging job, but it's not like job in the sense of like a Jenkins job. It's a job as in like, hey, we're gonna have thousands of users manually tagging our data for us. Is the job. And so you would pull a bunch of data related to, I would say maybe not even, and you would maybe do, maybe even have like the tagging job ID, because it might be, you might run like the tagging job like for bus like a few dozen times. You might have it like go through like a few dozen iterations of having the user like pull up different batches of the bus images. So you might have like this tagging job ID and what tag, like what are the users going to be labeling here? So it'd be related to bus data. And so you might have like that, and it's job ID 567. Yeah. Okay. And then we have our responses getting recorded. And now we can go back to talking about this data model thing over here. So we've got these responses we're getting, and we're like recording. We're going to figure out like for a given job ID, right? What was the result for a given image UUID? Is it a bus or is it not? And then we're going to record the responses over here onto so for image UID X, did the users come to a consensus that it is a bus or that it is not a bus? That's basically what you're running. That's basically the query that you're running over here. And then you're going to be recording the tag up here over to the OLAP store. And then you're going to be using this tagged data to train a data model. So you're labeling some of the data, but you're also going to be at a model store. Here it is. Okay. So this is the thing that I'm missing. This is another piece that I was missing. So we have this model training worker. And it is going to pull data from, maybe I should just like copy this whole thing since it's getting cluttered already. We're working from right to left today. Should I go the other way? So Okay, and now we got our model training worker. I'm gonna zoom in. So we got this thing is pulling data from both of these. And then it's going to have this model that is going to stick in the model store. We're going to have this model store thing. It's going to have the result of its training work, put out a new data model. And then we'll have a deployment service. Well, so this is like a further downstream byproduct of what we've got, but you can also take this, it would pull latest data model, and you'd say, okay, let's relabel all that data with the latest model trained off of the, so you've got your user entries, what's the new consensus on certain images, you got your labels there. All right, let's train the model off of it. Very cool. Now let's have it rerun a bunch of labeling on a bunch of data. And it's going to pull in that stuff and give a the model's output. How does the actual model results compare to the expected results from the users? And you can do that. Okay. Any questions on this? I'm thinking we're not going to do any machine count estimates or latency estimates on this. The diagram was already kind of crazy enough. I haven't seen anybody else try and do a diagram on CAPTCHA. So it was kind of a mess tonight, but I'm still kind of happy with what I made. So yeah. Okay, I don't see any questions, so I think we can wrap it up. If you guys do have any questions after we end the stream, feel free to post them in the comments below the video. Otherwise, I'll post the files in a pinned comment and on the Discord channel, of course. Thanks for joining. I will see you guys next time. I hope you had fun. See ya.